So in number 27, part A, we wanted a vertical asymptote, or vertical asymptotes at x equals -1 and x equals 1, and then a horizontal asymptote at f of x equals -3. So the thing to remember is that to get vertical asymptotes, we usually divide by 0. So that means we would need factors in the denominator that when they're set to 0, f of x, or the denominator would equal 0 when x equals -1 or x equals 1. Now doing this, we end up with a second degree polynomial in the denominator. And for the horizontal asymptote, we need to remember the horizontal asymptote rules. And if we want the horizontal asymptote to just be a constant, we need the ratio of the leading coefficients to be that constant. So I would need an x squared in the numerator, and what I would want would be a coefficient of -3. Because that would give me a ratio of leading coefficients of -3. And that would do it. Now, do you want me to do the two part B's as well? Okay. Alright, the first part B, we wanted a vertical asymptote at x equals 4. And we wanted a horizontal asymptote, or an EBA, if you prefer, when f of x equals 2. Excuse me. So, first thing I'm going to look at is the vertical asymptote at x equals 4. So that means I'm going to want x minus 4 in the denominator. And to get the ratio of leading coefficients equal to 2, I want a 2x in the numerator. Now I could add something down here if I really wanted to, but I need the 2x. The ratio of leading coefficients is what matters. Now, the other part B that you were supposed to do was we wanted vertical asymptotes at x equals -3 and x equals 3, and a horizontal asymptote at f of x equals 0. So, to take care of the vertical asymptotes, I want x plus 3 and x minus 3 in the denominators. Now, this gives me a second degree polynomial in the denominator, and to have 0 as a horizontal asymptote, I need the degree of the denominator to be larger than the degree of the numerator. So as long as I only have something raised to the x power, or to the first power, I can put whatever coefficient I want on there, and I can add whatever constant I want, and I still have a horizontal asymptote at 0, because if we multiplied this out, we would get the 32x plus 367, and this ends up being over x squared minus 9. Well, again, as those dominant terms start to take over, as x gets really big, those constants at the end don't matter. And that x would cancel out with one of those, 32 over x, and think about the limit as x approaches infinity. Right? That's going to equal 0. Okay? All right.